This is a APC Smart UPS model SUA750XL. This UPS has a pure sine wave inverter and it is a line-interactive UPS. It uses a 24 volt DC battery system. I bought this UPS in 2010. It is now 15 years old and has just failed. I opened up the UPS to have an investigation, but decided that being a 15-year-old UPS, some of the electronic components would have aged significantly, and from a fire safety reason, I preferred to buy a new UPS. This APC UPS has a power factor of 0.8. So it consumes 750 volt amps and provides 600 watts of power. My old APC UPS served me well. It lasted 15 years and in my view that's a decent length of time. To replace that APC UPS, I bought this Powershield PSCRT2000 Commander UPS. It is a line-interactive UPS. There are broadly three categories of UPS types. There is the lowest grade UPS, which is a standby UPS. The next high grade up is the line interactive UPS, and the highest grade is the online double conversion. So this is a line interactive UPS with a DC to AC inverter that generates a pure sine wave, and the UPS is installed with 4x12 volt DC 9 mAh AGM lead acid batteries. Here I just have the UPS powering a heater fan. Join me in this video as I unbox the packaging this UPS came in, show you what the contents are inside, and then set it up and run through the features, including how the software NetGuard can be used to monitor this UPS. So to open up this UPS, on the two top left and right hand sides, I pry open and this front plastic cover will come off. This is what the rear of the front panel looks like. And there's this circuit board which is clipped into the front here, and there are two push buttons here. One is for power on off, the other is for test, and the push buttons activate these two switches here. However, the power switch and the test switch would not activate. It may be the flat ribbon that is failed, or it could be the parent circuit board inside that has failed. This is what it looks like inside with the battery removed. It uses an Anderson SB50 DC power connector, and these are two 12 volt DC batteries cabled together in series to provide 24 volt DC. These two batteries are dry power 12 SB20C 20 mAh batteries. They are not cheap, but they're 6 years old, and I used a load tester and they fail. This is the rear of the APC SUA750XL UPS. The reason I bought this model UPS is because at the rear it has an Anderson SB50 DC power plug. This plug enables me to connect a 24 volt DC auxiliary power bank to supplement the battery power to the inverter. This is the Powershield Commander PSCRT2000 UPS. Let me unbox this. We have the UPS itself, we have the user manual, and we have two cables. One of them is a RS232 cable. The other cable is a USB 2.0 cable. We have a power supply cable with Australian GPO outlet plug on this end, IEC plug on this end. Here we have two brackets for rack mounting the UPS, and in these two pockets we have the plastic feet for mounting the UPS in a vertical upright position. I put the box in an upright position to make it easier for me to pull the UPS out because it is very heavy. It is about 21.5 kilograms. It is heavy because it has a 2000 volt amp inverter as well as four 12 volt 34 watt AGM VRLA batteries. Each battery weighs 2.5 kilograms, so the 4 batteries weighs 10 kilograms. These are all the components that came in the package. The UPS, the 2 sets of feet. How to assemble these feet: put them like that, cross them, and then they interlock. 2 sets of rack mounting brackets and 4 screws for each bracket. There is a RS232 cable. This is USB type A 2.0 plug at this end and USB type B 2.0 plug at this end. For the AC power cable, there is an Australian GPO plug and IEC C13 plug. Some dimensions of the UPS. In the specifications, it says the length is 480 millimeters. That is measured from the rear of the metal chassis to the front of the metal chassis, which is here. At the rear here, there is the emergency power off function connector. It actually protrudes out from the rear of the metal panel about 12 millimeters. And if I measure from the rear metal panel to the front of the plastic cover, it is about 515 millimeters long. The height is 438 millimeters and the width is 88 millimeters. If I set up the UPS in a vertical upright position on these plastic feet, then the height of the UPS becomes 446 millimeters. I will go through the various buttons, switches, connectors, wiring, sockets and plugs at the rear of this panel. This is the earthing ground cable to the chassis. This is the input circuit breaker. This is the IEC C14 male input socket. Behind this plate is an Anderson SP50 type DC power connector, which enables an auxiliary 48 volt DC power bank to be connected to this UPS. Powershield have a 48 volt DC power bank called the PSCRT2000 that is designed to take 8 of 12 volt DC 9 amp hour batteries connected in 4S 2P configuration. I will show what it looks like behind this cover plate. The plate protects against accidental short circuiting of the 2 contacts in there. This is what an Anderson SB50 type connector looks like. SB50 connectors are a good robust design and are used in a lot of industrial applications. And this is one of the main reasons why I bought this UPS. There are not many brands of UPS products that allow the primary UPS device to be supplemented with auxiliary DC power banks. And if a brand and model does have connectors that allow auxiliary power banks, sometimes the type of connectors used is proprietary or less generally available than this type of Anderson SB50 connectors. And hence this feature was an important reason in my purchasing this UPS. It has one extraction fan. This is the emergency power off function connector. There are 2 pins on the left and right side, and there's a metal joining clip that closes the circuit between these 2 pins. My guess is that this EPO is part of a relay circuit where power through this circuit activates a solenoid that then closes the circuit for the inverter and the battery system. And the mains AC circuit. I have not tested pulling out the EPO switch, so this is only my assumption and I may be wrong. How this EPO connector works can be configured in the LCD display panel. There are 2 modes. The first mode, called the AO or active open mode, is the default mode. In this mode, when AO is selected as EPO logic, it will activate EPO function with pin 1 and pin 2 in open status. When AC is selected as EPO logic, it will activate EPO function with pin 1 and pin 2 in close. I will just keep it in the default mode. This is the RS232 connector to allow communications to a computer. This is the USB Type B connector to allow communication to a local host computer. This is an intelligent slot which allows SNMP connection. This is a mini screwdriver set. I will use the largest Phillips head screwdriver to open up this intelligent slot. So that's the interface slot that allows an optional SNMP communications card to be slotted in. I do not intend to use the SNMP communications slot because I'll be using this USB port to connect to a local host PC. In terms of AC power output from the UPS, there are white colored programmable outlets. These white programmable outlets are to be used to connect to non-mission critical devices, and there are two black colored AC power outlets. These outlets are called general outlets, and mission critical devices are to be connected to these black outlets. So these are three Australian 3-pin power outlets, and these are the IEC C13 power outlets. Obviously, when Powershield is shipped to other countries, whether the US or Europe, the manufacturer would change these to the GPO outlets compliant to each country. All these white colored programmable outlets can have their backup time limits set from 0 up to 999 minutes. Obviously, that time limit depends on whether auxiliary power banks are connected to this UPS. Similar to the white programmable power outlets, the black general power outlets for mission critical devices can also have its backup time configured from 0 to 999 minutes. I will plug an AC power source into this AC input socket. This is a 9-watt LED light globe. I'll connect it to this programmable outlet. This is a 100-watt soldering iron. I'll connect it into this general power outlet for mission critical devices. With AC power connected to the UPS, the display shows the input power is 238 volts. The battery state of charge is 100%. There is zero load on the left hand side that says OK, and there's a symbol of a battery with a lightning icon inside. That means that the battery is receiving charge from AC power supply. Because I have the UPS set up in a vertical upright position, I've selected the display mode to match my vertical upright setup. If this UPS was to be turned horizontal so that it's installed in a equipment rack, then I can change the display mode so that it matches the horizontal setup. To do that, press the off/enter button and the select button together. And there we have the display mode turned so that it will match a horizontal installation. At this time, the display menu is on, however the UPS is not turned on. To turn the UPS on, press the on/mute button for 2 seconds. So the UPS is now on. Says the input voltage is 237 volts, and the UPS, if required to operate in battery mode, would last 2.0 hours. There is an ECO symbol, echo mode. That means that it is operating through AC power supply. There is a symbol of a black IEC C13 connector. That means that the programmable outlets are working. The load symbol shows 25% load. That load is coming from the 9-watt LED light globe connected to the programmable outlet, and also from a 100-watt soldering iron connected to the mission critical general outlet. I will now demonstrate what happens when I disconnect AC power input. What I expect to happen is that the light globe will turn off since it's connected to the programmable outlet, where I have set the time to 0 minutes, so it should shut off immediately or near immediately, whilst the 100-watt soldering iron should still be on, so it should show a load within the 25% bar, and the ECO icon will disappear and the fan will be activated because the inverter will be running. So I've disconnected the AC power input. You can hear the fan is now operating. The light globe is turned off. The 100-watt soldering iron is still powered, so it shows the load is 25%. The battery icon does not show a lightning symbol. That means there is no AC power charging the battery. And the input shows 0 voltage since there's no AC input supply. I have here a DOSS SPL1588 sound level meter. I have selected it to apply a C weighting to sound frequency, which means that it will weight more low frequencies. I've also selected the sound level to be low because in the specifications for this UPS it states that in line interactive mode the sound would be less than 45 decibels, and in battery mode the sound level would be less than 55 decibels. I have also selected a fast time weighting, so with the microphone at a distance about 400 millimeters away from the UPS front, I get a measurement of about 47 decibels. At a distance about 200 millimeters, it is about 50 decibels. I will now disconnect the soldering iron because I don't want it to be too hot since I'm not actually using it. To demonstrate how to use the menu to change the 9 settings parameters available. To get into the settings menu, I first have to turn the UPS off. So press the off enter. It's now off. It says OK, but the UPS is not active. I've reconnected the AC power input, so the battery icon shows a lightning symbol inside. The UPS is off. The fan has just started because I've just restored AC power. Press and hold the select button for 3 seconds to get into the settings mode. It is now in settings mode. There is a symbol of a spanner here. 01 is to select the output AC voltage. In this case, the output voltage has been set to 240 volts AC. If I want to change that voltage, I press enter, and then the voltage will start to blink, and I can use the up or down arrow key to change the value. .240 volts AC is the highest value. and I'll keep it at 240 volts output AC voltage. Press enter. To go to setting 02, press the down arrow key, and setting 02 is to enable or disable the programmable outlets. There are only two options. In this case, it has been set to enable. If I press enter, the setting value blinks, which means I can change it. I can press down, which says DRS, which means disable, and I press again, it says enable. So I want disable, so I'll press again. Press enter to keep that. Go to setting number 03, press the down arrow. 03 is blinking. 03 is to set the backup time limit from 0 to 999 minutes for the programmable outlets which connect to non-critical devices on battery mode. In this case, I will keep it at 0 minutes, but if I wanted to change it, I press enter. That blinks, then I can press whatever time I want, 6 minutes, 7 minutes or more, and if I push it backwards, it'll go to 999 minutes, and if I go back 998, but I want 0 minutes, so I do not want the UPS to back up the non-mission critical power outlets. I'll select that, press enter. Press down arrow key for setting 04. Setting 04 says site fault detection to enable or disable. If I press enter, that blinks. Press down arrow key, it shows me the second option, which is disable. I want to enable site fault detection, so I'll keep that ENA. Enter. Now to go to setting 05, press down. 05 blinks, press enter. Setting 05 is to set the backup time in minutes from 0 to 999 for general outlets on battery mode. This is the mission critical power outlet. In this case, I say 999, which means that it's 999 minutes, but essentially no longer than how long the battery pack is able to sustain the UPS. So I'll keep it at 999 minutes. Press down arrow key to go to the next setting, 06. Setting 06 is to tell the UPS the total MR capacity of the battery system. In this case, my UPS only has the default 9 MR battery, but if I connect the PSCRT2000 auxiliary power bank, that power bank has 18 MRs, and the total MRs then will be 9 plus 18, giving 27. So I will then need to change this to 27, and I'll do that just to demonstrate. With an auxiliary power bank, I can change the total MR setting to 27. This UPS is only permitted to connect to one auxiliary power bank, not to two. If I press again, since I do not have an auxiliary power bank, I'll return the total MR to 9 MR. And press enter to keep that. Go to setting 07. Setting 07 is the EPO logic setting. It's the emergency power off setting. AO means active open by default. When AO is selected as EPO logic, it will activate EPO function with pin 1 and 2 in open status. The alternative is AC, which means active close. When AC is selected as EPO logic, it will activate EPO function with pin 1 and 2 in closed status. But I want it to be AO, which is the default setting. Press enter to keep. Down arrow to setting 08. Setting 08 determines how sensitive the UPS is to treat the input voltage waveform. There are three options. There is ST1, which is highly sensitive. Alternatively, setting ST2, where waveform detection is medium sensitivity, and that is the default setting. And finally, setting ST3, wherein the waveform detection is set at low sensitivity. I will return it to setting ST2, which is medium sensitivity and is the default setting. Press enter. Go to setting 09. Setting 09 has two options. AON means LCD display backlight is on all the time. Alternatively, AUT, which means LCD backlight will be off after pressing the buttons 60 seconds. That is the default setting. I will select AUT setting. Press enter. Press the down arrow and it shows setting 00, which means escape. So to exit the settings mode, I press enter. And there we are. We've finished going through the 9 possible settings for the UPS. I'll turn the UPS back on. Press the on/mute button. The light has turned back on because it's connected to the programmable power outlet. At the top right hand corner, it says input 238 volts. Press the down arrow key. It says input is 50.0 Hz. Press the down arrow key. It says that the battery is 54.7 volts. Press down arrow key. It says the output voltage is 239 volts. Press down arrow key gives me output is 50.0 Hz. Down arrow key again brings me back to the input voltage is 238 volts. The power capacity of this UPS is rated as 2000 volt amps and 1800 watts. This means that this UPS has a power factor of 0.9, which is very good. It is a line-interactive UPS with an inverter that generates a pure sine wave output. The UPS provides overload protection, thermal protection, short circuit protection, discharge and overcharge protection, and the surge protection is rated as 2064 joules. The UPS also provides built-in buck and boost automatic voltage regulation. To access the internal battery bank, it is behind this front plastic panel. To remove this front panel, there are 2 plastic tabs facing upwards and there is 2 plastic tabs slotted inwards about here. I have to grip the bottom and pull out like that. So there are 2 plastic tabs. They slot into these 2 plastic catches, and here are the vertical tabs as well that point upwards. This is a DC power connector made by Anon. This UPS incorporates hot-swappable internal battery packs. This means that I should be able to disconnect this battery from the UPS system whilst the UPS is connected to a AC power system, and it should not interrupt the AC output to the load devices. So when I disconnect this plug, the light globe should continue to be lit. There we are, the battery pack is disconnected. The light globe has remained on because it's been powered through the AC mains power. So this is the benefit of a hot swappable battery system. I can remove the battery pack and reinstall a new battery pack that is fully charged without the load devices suffering disconnection. Strange, the disconnected battery alarm is beeping. I do not understand why, given the fact that it's supposed to be a hot swappable battery. I contacted Powershield technical department, who explained that if the UPS coincidentally started a self-test at the time when I had disconnected the battery, it would trigger the alarm. So that explains it. I'll now attempt to remove this battery pack, and I think it is the 4 screws here, 1, 2, 3, 4. You have to be careful to lift this fully, and then there's a plastic pull tab. Pull this out and the battery slides out, and on the side there's a sticker which says there are 4 pieces of 12 volt 9 mAh battery. Nominal voltage of this 4S string is 48 volts and nominal capacity of the string is 9 mAh. Push this back in, slide this through, reinstall the 4 screws diagonally. Alright, the metal cover plate is reinstalled with the 4 screws and tightened. I can reconnect this DC connector. The alarm is still beeping even though this is reconnected, so I suspect what I have to do is turn it off. Turn it back on. Yes, the UPS is back on. It shows the battery icon with the lightning symbol. That means the battery is detected and is charging, and the alarm beeps have stopped. I will repeat my test of disconnecting the battery from the UPS to see if the alarm beeps. So battery is now disconnected. Strange, the battery icon still says that there's a lightning symbol. That means that the battery is charging. I'll wait a while to see if the alarm does beep. So this lightning symbol in the battery icon indicates that the battery charger is working. But with the battery disconnected, nothing's happened. So I actually wonder what that means. Why hasn't the battery disconnected symbol lit up? I've waited for a few minutes now and the battery disconnect warning has not sounded. I checked with Powershield technical support and I'm told that it takes a little longer time for the UPS to detect battery is not connected, and then it will show the correct battery symbol. I'll reconnect the battery, restore the plastic front cover to the UPS, the 2 plastic tabs on top, slot it in first, and then because the 2 plastic catches are around here, do not push anywhere up here, push in around this position, and there it is, secured. UPS is now sitting horizontally. I think I now understand how the battery disconnect alarm works. The detection system I think operates on a polling time interval. So if I disconnect this cable at a time outside the polling period, the alarm will not trigger. On the other hand, if I disconnect the cable within the polling time period, then the alarm will trigger. So it will be interesting to see how long from when I disconnect the cable to when the battery disconnect alarm is triggered. I will use a stopwatch to see how long it takes before the battery disconnection is detected. Disconnect cable now. Start timer. One minute passed, no alarm. 3 minutes passed, no alarm. 4 minutes passed, no alarm. Right, the alarm just triggered. That was about 4 minutes 15 seconds thereabouts. Perhaps it's a polling time interval detection system, or perhaps this 4-minute time interval is a grace period for someone to change the battery. I do not know. Reconnect the battery, and the alarm will still be active. To turn the alarm off, I have to turn the UPS off. And alarm will still be active. Now I turn the UPS back on. So the battery disconnect alarm is not active anymore. The UPS has returned to a normal operating state. The battery symbol shows a lightning icon inside that it is receiving charge from AC mains. At the time when the battery disconnect alarm was active, the battery symbol was blinking and there was no lightning icon inside. And in addition, there was a hazard symbol blinking on top. In any case, it is important to have a battery disconnect alarm. There is obviously a time interval between when the battery is disconnected to the time when the alarm is active. Whether that time interval is due to a polling time system or it is a grace period to enable someone to change the battery, I do not know. But as far as I can tell, the UPS is operating properly. So that's good. If I was installing this UPS horizontally into a rack system, then there are two rack brackets I need to fix to the front, left and right hand side of the UPS. This bracket is marked L, this bracket is marked R. So this being the right hand side of the bracket will be installed like this, with 4 screws securing the bracket to the chassis of the UPS. The slot holes on top facing the front, and the extended L-shaped flange at the bottom facing forward. Now I want to download the NetGuard management software and install it to my computer. So I'm at the powershield.com.au website. Go to support, go to software downloads, click on that. I have a Commander RT UPS, so I want NetGuard software. Click on that. It shows that the NetGuard software is available for 3 operating systems: Windows, Mac and Linux. I have a Windows computer, so I'll click on NetGuard for Windows. The screen shows information about the software. It's NetGuard version 1.04-23292. I think what this means is the file has been downloaded 33,022 times and the file size 145 megabytes. Notice that there is no clickable icon. What I have to do is scroll down to this box. In this box, if I move the cursor to the left, the download button appears. This is a software bug, and I'm sure Powershield will fix this soon. Click on download, and the download has begun. The download is complete. Click on this. The software is called Install NetGuard Windows, so it's 145 megabytes file size. Double click on this. Windows User Account Control asks if I will permit this software to install. I say yes. The installation uses a software called Install Anywhere. This process is to install NetGuard version 1.04. At stage 1, it says to choose install folder. Where would you like to install? My strong recommendation is not to change this. Keep the folder as C/NetGuard because I have previously tried to give it another folder name, and even though it completes the installation, the NetGuard software will not start. So it does not work when I try any other folder, so I keep it to the default. Press next. It asks where I would like to create the product icon. I'll choose the default in a new program group called NetGuard. And if I want this software available to all users on the computer, I could press all users, and I'll do that. Then press next. So it confirms my choices. I'll press next and give permission to start installation. Tells me, congratulations, NetGuard has been successfully installed. So press done. Now that I have installed Powershield NetGuard software on my Windows 11 laptop, go to the bottom tray. That is the icon for NetGuard monitor system, beeping a heartbeat indicating that a UPS is connected to the local host computer. If I right button click on this icon, it brings up the various options: stop monitor, configuration, debug, open monitor, exit. If I open monitor, it opens up a web browser which communicates to the UPS. This is my laptop. This is the USB interface. It gives some high-level information about the UPS. UPS type, line interactive, input phase, output phase, single phase AC power supply, the serial number of the UPS, the firmware version of the UPS 02625.0201, purchase date of the battery. It says the purchase date is today. I suspect that is because I pulled out the battery during my demonstration. I have the opportunity to remind me when to change the battery, but that's disabled. In this left button, I can view these various options. Status, that shows the power flow of the UPS. At the moment, it says the input information, input voltage 236.9 volts, input frequency 50 Hz. So AC input, because it's line interactive, it shows the flow passes and out through the output. The UPS is operating in line interactive mode. Temperature of the UPS 25.7 degrees Celsius. Output voltage 237.1, 50 Hz, zero load. It's zero load at the moment because I only have a 9 watt LED light glow, so the sensitivity is too low to detect. The AC input goes to a converter which converts AC to DC waveform, and that charges the battery. The DC to AC inverter is not activated, as you can see, because the line is grayed out. UPS information, it shows the battery capacity is 96% and there's zero load. UPS information, battery information, output information. Diagram, which is presently showing input voltage graph, input frequency graph, output voltage graph, output frequency graph, the load current, and because it's only a 9 watt load, it doesn't show up on the graph. The load level, similarly, battery voltage, UPS temperature. What I will do is connect the 100 watt soldering iron and see if this changes. I have just connected the 100 watt soldering iron. The load level still doesn't show up. It took some time for it to recognize it. So now the load level shows my soldering iron. The horizontal axis is obviously time. I think the graph shows 100 watt output is 5% of 1800 watts UPS capacity. It says current is 0.4. That sounds about right. I think that is 0.4 amps, because 0.4 amps multiplied by approximately 240 volts gives you 96 watts, which is close to the rated 100 watt power consumption of the soldering iron. Go back to the power flow. Go back to UPS information chart, and it now shows the load level is at 5% because I have a 100 watt soldering iron connected. Current is 0.4 amps. At output voltage 237 volts. So that all looks correct. Go back to UPS, click on history. It shows event log, event statistics, data, diagram. Go back to UPS settings. Let's see what local shutdown says. Click on local shutdown, see what it says. It brings up this menu, the options to shut down the UPS. I will choose to shut down the UPS when the battery capacity is down to 20%. Some of the options. See what remote shutdown options are. I will not be using the UPS with remote access control. Parameter settings, see what it says. Took a while to get to parameter setting. UPS alarm enabled, yes. Alarm at battery mode enabled. Auto reboot enabled. Green power function disabled. Battery open status check is disabled. I'll say enable. Before I do anything else, I might click on login, and it asks for the password. Login monitoring system, the username by default is administrator, and the factory default password is administrator. I'll try that. Login, select outlet setting, see what that does. Cold start, battery deep discharge protection is enabled. Site fault detection, it is enabled. P1 programmable outlet control, P2 programmable outlet control. I do not know which are P1 and P2. This is ambiguous to me because in the hardware user manual, it only refers to programmable outlets without reference to P1 or P2. However, in the NetGuard user manual, it refers only to P1 programmable outlets, no reference to P2 programmable outlets. So this is ambiguous and confusing to me, but perhaps I'm just overthinking it. I'll click on the disable button. I am waiting. It takes a while for the UPS to respond after I click. It says disable setting successful. So what this indicates to me is that it is the orange or brown text that is the setting configured in the UPS. Under outlet setting, backup time for programmable outlets is 0 minutes. The number of batteries in parallel is 1 because it is only the built-in battery pack. Battery max backup time 999 minutes. Voltage range for eco mode, let's see what that says. Perhaps I'll put this as 245 volts maximum and 225 volts minimum. Go to purchase information, and here I can input some purchase information. Go to control, real-time control. So this allows me real-time control of these features. I can schedule on and off. I can schedule battery tests. Looks like there are 3 types of tests that can be carried out. A 10-second self-test, a self-test where I define the test time, and then a deep discharge test. I can go to configuration and define settings for these various parameters, but I will not cover it here. I will now disconnect AC input power in order to show the power flow when the DC to AC inverter is activated. Here we are. I've now disconnected AC input power. Let's see how long before NetGuard software provides alert and changes the power flow diagram to show AC input now coming from the battery powered inverter. About 23 seconds later, NetGuard alerts of AC input failure. NetGuard just updated power flow diagram to show battery powered inverter now working. As a result, the P1 programmable outlet power has been switched off. That is correct. And the power flow now shows that there is no mains AC input power, and instead the battery is supplying power to the DC to AC inverter. So this is working correctly, and the UPS is operating in battery mode. I will reconnect AC input power and we will see the graph restored to AC input power flow. Here we are, the AC power flow has been restored. The UPS is working correctly. That's good. So in summary, what do I like about this UPS? I think it's well built, it looks robust. I can use it in a horizontal rack position, or I can use it as a floor standing tile, and the display can be configured for horizontal or vertical use. It has an inverter that generates pure sine wave. It is a line-interactive UPS, so better than a standby UPS. Has automatic voltage regulation, has buck and boost voltage regulation. It has a power factor of 0.9, which is good, and it also has the ability to connect to an external battery pack in order to extend the total amp hour capacity of this UPS from the built-in 48 volt 9 amp hour to a total of 27 amp hour, the addition of one external battery pack. The user interface display looks clean, simple and clear. I have no difficulty reading the text and the values. However, it does take a bit of getting used to in order to operate the buttons and the settings menu, because it is a simplified LCD display, but I do understand and accept that. I like the fact that the UPS has a hot-swappable battery system, and it also has the NetGuard software which runs on Windows 11, and also some versions of Mac and Linux operating systems. Unfortunately, I have not found in the user manual any instructions or ability to upgrade the firmware in the UPS, not even when connected via USB cable to a local host PC. That's okay if the firmware is of a high quality and there are no bug fixes required in the future going forward. I've shown how NetGuard software on Windows 11 PC operates with a simple user interface to enable monitoring the UPS system, and that is good. I hope you found this video interesting. I look forward to using this UPS. Do hit the like button and subscribe to my channel for more and help the channel grow. Thank you so much.